Hello, and thanks for clicking on this next Algebra 1 production. Today, we're going to be talking about how to factor trinomials. Okay, trinomials in the form x squared plus bx plus c. So this is our third method of factoring that we're going to talk about. So let's get started. It's a little bit different than what we've done so far. So let's get the show on the road. All right, so before we start factoring, what I want us to do here is I want us to multiply each one of these sets of binomials. So I'm asking you to multiply these two sets. So we're going to do it with the distributive property. If you remember, we're going to distribute x to each one of those, each one of these terms in the other binomial there. So x times x will give me x squared. And then if I do the x times the 4, that's a positive 4x. And then if I multiply the 3 times the x, and 3 times the 4. 3 times x is 3x. And then 3 times 4 is 12. All right, so I put my like terms together, and I get x squared plus 7x plus 12. So that's what my answer comes out to be, okay, when I multiply these two binomials. Now remember, the goal here is all the same in factoring, is to take this this trinomial that we have, x squared plus 7x plus 12, and make it look like x plus 3 times x plus 4, right? We want to try to factor it. We want to undo the distributive property to make it happen. Okay, so let's try the second one. We're going to multiply that as well. So let's take the x. We'll distribute it to each one. X times x is an x squared. X times positive 2 is a 2x. Then we'll take negative 7 and distribute it. Negative 7 times x is negative 7x. Negative 7 times 2 is negative 14. I'm going to put my like terms together. I get x squared minus 5x minus 14. And this is the correct multiplication of those two binomials. Okay? Now, what I want you to see between the two problems that we just did here is the steps that we followed and the answers that we got. So the first thing we did was we multiplied x times x, and that gave us this x squared that's here. Okay, then we did x times the 4, and then we did 3 times the x, which gave us the 4x and the 3x, and then we combined them because they were like terms, and that gave us a total of 7x. And then finally, the number, we did 3 times 4, and that just gave us 12. So we brought that down, okay? And then in B, we did the same thing. We did x times x, and that gave us our x squared that we see in the answer here. X times the 2 was 2x. X times negative 7 was negative 7x. We put the like terms together. We combined them, and that gave us the negative 5x. And then finally, the negative 7 times the 2 was negative 14. And then that negative 14 is what appears here. Okay? So that's how we got our two answers. Now, the idea of how we got them is actually what we're going to use to be able to factor from x squared minus 5x minus 14 back to x minus 7 times x plus 2. We're going to use that concept of how we multiply two binomials to come up with this answer to go backward. Okay? All right, so let's take a look. The goal here is to factor a trinomial. X squared plus b is some number, and so is c. Doesn't have to be the same number as b. They can be different. That's why they're named with two different letters. All right. We're going to factor the trinomials in the form x squared plus bx plus c. So to do that, the first thing we're going to do is we're going to look to see if there's a GCF. We're going to factor the GCF if there is one. That GCF has to be something other than 1. If it's just 1, then you don't have to factor a GCF out at all. Okay? Now, to factor these trinomials, here's how we're going to do it. We are going to find two numbers. They're like, each problem is like a small puzzle. Find two numbers that multiply together to be C. They have to multiply to be C, and then they have to add together to be this number B. So some teachers call this factoring 1AM. There's a 1 in front of the x squared. You don't see it, but it's there. The two numbers that you find have to add up to be this number b in front of x, and they have to multiply to be the number by itself, c. The two numbers that you find must accomplish both tasks at the same time. They have to both multiply to be c and add together to be b. They have to do both. Okay? And then we're going to use the two numbers, one in each factor, to factor the trinomial. All right, so it looks awfully complicated. It sounds awfully complicated, but I promise you it's not as complicated as it looks. All right, so let's try a few, and we'll see if we can get the hang of it. Okay, we're going to start by trying to factor x squared plus 6x plus 8. All right, so again, some teachers would call this, okay, this is a trinomial. There are three terms. They call this 1am. So the first thing I'm going to do is look for a GCF. Between 1, 6, and 8, it's 1. This one has 2 powers of x. This term has 1 power of x. This term doesn't have any, so I can't take any powers of x out. So 1 is the only GCF. So I don't have to do anything. All right? Now, here's what I want to do. I want to find two numbers. These two numbers, they have to multiply to equal 8. And they have to add to equal 6. It has to be the same two numbers that accomplish both tasks at the same time. All right, so we hunt around. I usually start with the numbers they have to multiply to be 8. Start with all the ways you know to multiply and get 8. So 1 times 8, that doesn't work because 1 plus 8 is 9. So that's no good. 2 times 4, oh yeah, that's it. Because 2 times 4 is 8 and 2 plus 4 is 6. So my numbers are 2 and 4, both positive. Okay, positive 2 and positive 4. Now, I'm going to factor x squared plus 6x plus 8. Here's how it's going to factor. I need 2 sets of parentheses. I need an x in front of each set of parentheses because x times x is going to give me x squared. And then I'm going to follow with these numbers, one in each set. So it's positive 2 and positive 4. Those are my numbers. This is done. It's been factored correctly, and I'll show you why. If I come down here and I check it, let's check it. If I multiply it through x times x, that gives me the x squared. There it is. X times 4, that's only 4x. But now if I go underneath, 2 times x is a 2x. And 2 times 4 is 8. And when I put my like terms together, I get the x squared, check. 4x plus 2x, that's 6x, check. And there's the 8, check. So this is factored correctly. X plus 2 times x plus 4. Okay, I'm splitting this x squared up into an x in the first set of parentheses and an x in the second set so that when I multiply them, it gives me the x squared. All right, let's try the next one. Same idea. So let's look for a GCF. We have 1, -9, and -10. Nothing other than 1. The first term has 2 powers of x. The second term has 1. And the third doesn't have any. So no GCF. Okay, that's good. All right, so now we're going to try to factor this. It has 3 terms. We're going to try to factor it with 1am. I'm going to find two numbers. They have to multiply to equal -10. And they have to add together to be -9. So if I multiply to be -10, that means one number has to be a positive and one has to be a negative. That's the only way to multiply and get a negative number. So it could be, let's see, 10 times -1. But 10 minus 1 is 9, not -9. It could be -10 times +1. Let's see, -10 plus 1. Oh, that's -9. And -10 times 1 is -10. There's my numbers. So my numbers are -10 and 1. Okay, so now I'm going to factor this. I want to take my x squared and I want to split it up. So let's do it. X here, x here. And my two numbers are -10 and +1. This is the correct answer. It's all done. Okay, again, if I were to double distribute, like I did in this problem here, I would get back to where I started again. That's the whole idea behind factoring. You just want to repurpose this equation or this polynomial. You want it to look different than it currently does. All right, let's try a few more. Let's try x squared plus x minus 30. Same idea. I'm looking for a GCF. So let's see. GCF, 1 is the only number that goes into 1, 1, and 30. And then this has 2 powers of x, 1 power of x, no powers of x. So nope, no GCF other than 1. Okay, so now it's got 3 terms. I'm going to try to factor this by 1am. Here we go. I need 2 numbers. Those 2 numbers have to multiply together to be negative 30. And they have to add together to be this middle term here. There's a 1 there. You don't see it. So they have to add to be 1. Okay, I'm looking for the 2 numbers that make it work. There's lots of ways to multiply and get negative 30. 30 times negative 1. Nah, no way that's going to work. That gives me 29 if I subtract them. So that's not going to work. Let's try 10 and negative 3 maybe. Nope, that's 7 if I subtract them. Nope. How about 6, or let's try negative 6 and positive 5. Well, negative 6 plus 5. Negative 6 plus 5. Nah, that's negative 1. Almost. I need it to be positive 1. So a trick is, if you switch these signs around, you'll get what you want. 6 and negative 5. Oh yeah, 6 minus 5, that's 1. And 6 times 5, negative 5, that's negative 30. So there's my numbers. So my 2 numbers are going to be 6 and negative 5. So now I'm going to factor this. I got my 2 sets of parentheses. I'm going to split up my x squared into x and x. So when I multiply, it would give me x squared. And then I'm going to stick the numbers in. We got plus 6. We got minus 5. And that's the correct answer. Please note, of course, you could write this if you did x minus 5 times x plus 6. That's absolutely okay because you're multiplying, and it doesn't matter which order you multiply. Right? 3 times 5 is the same as 5 times 3. So either one of these is more than acceptable. They're both the correct answer. Okay. All right. Let's try x squared minus 9x plus 14. Okay. Same thing. So let's check for a GCF. 1, 9, and 14. Nope. Nothing there. And then 2 powers of x, 1 power of x, no powers of x. Nope. No GCF. All right. So now we're going to try to, it has 3 terms, 1, 2, 3. I'm going to try to factor this by 1am. I need to find 2 numbers. They have to multiply to be 14 and add up to negative 9. Signs go along with the numbers. Okay. Well, multiply to be positive 14 and add up to a negative. Well, if I do 7 times 2, that's 14. 7 plus 2 is 9, but I need them to add together to be negative 9. So to do that, I can make both the numbers negative. Negative 7 times negative 2 is positive 14, and negative 7 plus negative 2 is negative 9. So those are the numbers that make it work. So my 2 numbers that I'm using are negative 7 and negative 2. So now this will factor. 2 sets of parentheses, multiplication in the middle. Split the x squared up into x and x. The 2 numbers have to multiply to be 14, so that's going to be a negative 7 there, a negative 2 there. Or you could switch it around, do x minus 2 times x minus 7. Either one of these is acceptable. Okay, there's your answer for that. All right, let's try a couple that actually have a GCF. So let's try 3x squared minus 6x minus 9. All right, so I want you to factor this. Okay. Well, let's look for a GCF. Oh, 3, 6, and 9. Yeah, 3 goes into all of them. I can take 3 out. All right, so let's take 3 out. 2 powers of x here, 1 power of x there, none there. Can't take any out. But I can divide all these by 3 and write what remains. So 3 divided by 3 is 1. And then I still have the x squared there. Negative 6 over 3, that's negative 2. And I still have the x there. Negative 9 over 3 is negative 3. All right, so far so good. I don't need the 1 here, so I'm going to get rid of it. Yep, and apparently also a piece of the x. There we go, we got it back. All right, now look inside here. Inside my parentheses, I have a nice setup for factoring a trinomial, 1, 2, 3 terms. So I am going to factor this by 1 a.m. Okay, so now this 3 that you brought out as part of the GCF, it comes down to the last line. It's part of your answer, okay, but it's not going to affect anything else you do inside the parentheses when you factor using this 1 a.m. method. So I need two numbers. They have to multiply to be negative 3. They have to add up to be negative 2. Let's look for the numbers. We could try 3 times negative 1. That's negative 3, but 3 minus 1 is positive 2. So that's not it. That doesn't work. But I just want to get negative 2. So if I switch the signs around, it'll work. Negative 3 times positive 1, that's negative 3. Negative 3 plus 1, that's negative 2. Oh, there we go. So there's my numbers. They're going to be negative 3 and 1. Okay, so now I'm going to factor this. I need my 2 sets of parentheses. Remember, 3 is part of the answer, okay, but it doesn't affect what we're doing when we're trying to factor the trinomial inside. X and x, and then I'm going to fill it in, minus 3 plus 1. This is all done. You also could have done x plus 1 times x minus 3 with the GCF out there in front as well. This is also acceptable. It's also the correct answer. All right. And again, if I were to distribute all this stuff, I'd get back to 3x squared minus 6x minus 9. Okay. All right. Let's try this last one over here. 2x cubed minus 10x squared minus 12x. All right. Let's look for a GCF, see if we can find one. Well, 2 goes into 2, 10, and 12, so we can take that out. This has 3 powers of x, 2 powers of x, 1 power of x. I can take the smallest, so I can take x out of there. And now I'm going to write what's left. Let's divide them all by 2x and see what we get. 2 divided by 2 is 1. 3 powers of x up top, 1 on the bottom, so there'll be 2 remaining. Negative 10 over 2 is negative 5. 2 powers of x up top, 1 on the bottom. That means there's 1 left. Negative 12 over 2 is negative 6. 1 power on top, 1 on the bottom. There's none left. So I have this so far. 2x times 1x squared minus 5x minus 6. Again, I don't need the 1. So let's get rid of it. Okay, now look inside the parentheses. This is a setup. This is a trinomial set up beautifully for 1 a.m. There's a 1 in front of the x squared. They got to add to negative 5 and multiply to be 6. So I'm looking for 2 numbers that multiply to be negative 6. They have to add up to be negative 5. All right, let's look for the numbers. If we try 3 times negative 2, that's negative 6, but 3 plus negative 2, that's 1. So that's not it. No good. How about 6 and 1? 6 times negative 1 is negative 6. 6 plus negative 1, that's 5. Nope, I need negative 5, not positive 5. So let's switch the signs around. So my 2 numbers are going to be negative 6 and positive 1. Those are the 2 ones that are going to make it work. And you can see it, negative 6 plus 1 is negative 5. So it sure does work. These are my 2 numbers. Okay, so let's take this 2x. We're going to bring it down. This is going to be part of our answer. And now we're going to take that x squared. We're going to split it into an x and an x. And we're going to put minus 6 here, plus 1 there. Or, again, we can switch them around. We could do x plus 1 times x minus 6. Both of these are acceptable. They are both correct. All right? They're both correct. Now, you may be asking yourself, well, what if it says x cubed minus 4x plus 2? Or plus 4, let's say. Well, then you can't factor it right now. Okay? This can't be factored right now. All right? That's not something we can do. It has to say x cubed. Okay? It has to say x cubed. Or, I'm sorry, it has to say x squared. It has to say x squared. That's why we took out the 2x up here, because you can't factor 2x cubed. Okay? Has to say x squared right now. If you look at all the examples that we did 1am. It has x squared minus 2x minus 3, x squared minus 5x minus 6. If we go back, this is x squared plus x minus 30, x squared minus 9x plus 14, x squared plus 6x plus 8, x squared minus 9x minus 10. Okay, all of them work with an x squared. All right, so that's how you factor a trinomial using the 1am method. There's a 1 in front of the x squared. The two numbers have to add up to be the middle number in front of x, and they have to multiply to be the number by itself. All right, and as always, thanks for clicking.